All right, so today we're going to look at proportions, and that's going to help us later when we're trying to look at slope also, which maintains proportions along a linear equation. Proportions are actually equations involving fractions or ratios, and because we're talking about slope in this unit, we're going to think of them as ratios. So let's go ahead and write this down. A proportion is an equation stating two ratios are equivalent. All right, so let's look at just a quick little example of a proportion. For example, if I have a portrait that's 2 by 3, length and width, it's the same image as creating a portrait that's a 4 by 6 because it will not be distorted, it'll maintain its proportions. How do I know that? Because I can multiply this by 2 and get 4, multiply this one also by 2 and get 6. So there's scale factor would have been a 2, meaning it got doubled or magnified twice the size. Another way you can also check proportions is by cross multiplying. So cross products of proportions are equal. So cross products of proportions are equal. And if you test the cross products and you get that they're equal, then you know. So 2 times 6 is 12 and 3 times 4 is 12. Therefore, I know that this is a true proportion. And another word that we can say is that 2/3 and 4/6 are proportional. Proportional is a word that we give this equation. It's when two ratios form a proportion. So the best way that I know how to describe something being proportional is like mixing colors or mixing paint. Say I have this perfect shade of lime green and it has 2 ounces of yellow and 3 ounces of green, but that's not enough paint. I need more. So if I were to mix 4 ounces of yellow with 6 ounces of green, because it maintains proportion, I should get the same exact shade of lime green, except just in a larger quantity. And this is a true application. When you want to paint something small or paint something large, the color will remain the same if the proportions are the same. So think of it as like a formulation or a formula or a recipe. You're just increasing it with the same proportions. It should not change the recipe of the flavor of the food or the color of the paint if it's proportional. All right. So let's look at an example. This one I'm going to give you a table. So given the table, tell whether x and y are proportional. I'm just going to put, given the table, are x and y proportional? Sometimes the tables are horizontal, sometimes they're vertical. I'll give you this one horizontal. And if your x is 1/2, your y would be 3. If your x is 1, your y will be 6. When your x is 3/2, your y will be 9. And when your x is 2, your y would be 12. Okay, so given this table, is x and y proportional? Well, the solution would be to set up proportions. We can't say they're proportions because we don't know yet. So set up ratios. And check if they're proportional. And the way that's going to look is we'll just say x over y equals x over y equals x over y. And our goal is to see that all of these ratios are indeed equal to each other. So let's go ahead and start that. The first one we'll say is 1/2 over 3. Is that the same as 1 over 6? And then we'll test, we'll compare them all to 1 over 6. Then we'll say if 3 over 2 for the x and 9 for the y, is that equal to 1 over 6? And if they all equal 1 over 6, then we're good. And the third one is comparing 2 over 12. Is that the same as 1 over 6? So we'll compare them all to that 1/6 and see what we get. I'll put a question mark because we're not sure. And the way we check this again is cross products. So let's check the cross products. What's 1/2 times 6? 3. And what's 3 times 1? 3. So that one checks. Again, you have another xy, xy. So I'm going to multiply these. 6 times 3 over 2. That would make this 18 over 2, which is 9. You want to put a 1 under there? If you know what I'm doing numerator with numerator, denominator with denominator, and that gives me 18 over 2, which I know is 9. And then I get 9 times 1, that's 9. So that checks. And 6 times 2, that's 12. And 12 times 1 is 12. That checks. So therefore, they are proportional. Yes, x and y are proportional. And there you go. Now, in the real life application, we have rates. Rates are a comparison of two quantities, and we can actually have rates that are proportional. So let's look at example 2. You swim 4 laps in 2.4 minutes. And then complete 16 laps in 12 minutes. Are your laps proportional to your time? Okay, so there's two methods of doing this. We want to know if the 4 laps in 2.4 minutes, is that the same rate as 16 laps in 12 minutes? Meaning, did you speed up, did you slow down, or are you maintaining your speed? If the laps are proportional, then that means you are performing the same before and after, earlier and later. So, and if they're not proportional, that means that your speed of swimming is changing and you're slowing down, speeding up. That would mean not proportional. So let's see, method 1. Method 1, you can actually compare the rates. I want to know how many laps, how long does it take me to do 1 lap? And then I can compare. And then method 2 is going to be to just set up the proportion and use cross products. So I want to compare unit rates. And comparing unit rates means how long did you go per lap? How much does it take you to do each lap? So we know that it's 2.4 minutes for 4 laps. And I want to find the unit rate, and I want to know how long it takes you to do 1 lap. So 4 to 1, that means I divide by 4. 2.4 divided by 4 gives me 0.6. So 0.6 minutes per lap. That's my rate. And then the other one, I did 12 minutes. And that was for 16 laps. What was my speed for that one? How long did it take me to do 1 lap? So the rate would be divided by 16, divided by 16, 0.75. So when I did this scenario, I was going 0.6 minutes for each lap. And then when I went to 16 laps in 12 minutes, that meant I was averaging 0.75 minutes per lap, 75 hundredths of a minute each lap. So clearly the rates are not the same, so therefore they're not proportional. And if you're curious how I got those numbers, I was just dividing. How do I get to a 1? 16 divided by 16 is 1, and 12 divided by 16 is 0.75. How does the 4 become 1? Divided by 4. So 2.4 divided by 4 was 0.6. Okay, so now let's look at method 2. If you didn't want to figure out how fast you did each lap, you could actually just compare the units. Compare the ratios and make a proportion or set them equal to each other and check if it's proportional. Is that the same as doing 2.4 minutes and 4 laps? Okay, so we're going to question ourselves. Are these two ratios equivalent? If they are, then we say they're proportional. So then you're going to do cross products. Cross multiply here and cross multiply here. And 12 times 4 is 48. And 16 times 2.4 is 38.4. Clearly, those numbers are not equal to each other, so therefore it's not proportional. Cross products are not equal, so they're not proportional. So we say nope. Not proportional. All right, and there you go.